All right, we're going to look at number 45. Okay, and I think I covered pretty much the theory before, so I hopefully you can deal with the laws of logs. Okay. What's the intensity levels in decibel? So of sounds with intensities of that. So intensity level or the decibel level is different than intensity. The intensity is your I, the decibel level is your beta. Okay. So 10 times 10 to the negative 12, so you have to do beta is 10 log of 10 to the negative 12 over, 1 times 10 to the negative 12 over threshold of hearing, which is also the same. Now you know that log of 1, this is 1, is 0, so this is going to be just 0 decibels, right? Okay. If you do 5 times 10 to the negative 6, you do the same thing, so it's just going to be, this is going to stay constant, and this is going to be 5 times to the negative, times 10 to the negative 6, and you can solve that equation. Okay, and for that one, it should be 67 dBs, decibels, right? Let's look at 46. What is the difference in the decibel level if the intensity of a sound is doubled? I think I talked about this in the previous video, but I'll show you again. So here is your new decibel level. Is going to be 10 log 2 times the intensity over the threshold of hearing, right? The intensity for the threshold of hearing. So now if I break this up into these two pieces here, so it should look like this. It should be 10 log of 2 plus 10 log of I over I naught. When this here is your old beta before you doubled your intensity. So if you do 10 log 2, you should get about 3. So your decibel level will increase by an additional 3, not a factor. Okay. By what factor, 47, by what factor does the intensity increase for intensity level difference of 10 and 20 decibels? So if there is a difference of 10, your intensity should increase by 10 folds. If there is a difference of 20, that's 2 tens, and for each 10 you multiply the intensity by 10. So that should be 100. Okay? And I think I talked about that in the previous video. All right, number 48. A noisy typewriter produces a sound of intensity 1 times 10 to the negative 5, that's I. Find the decibel level of this machine. So I think beta is 10 log of 1 times 10 to the negative 5 over 110 to the negative 12. And that should just be 70, it looks like. Okay, you don't even have to put that in the calculator if you know your rules of logs. Okay. Okay. Find the decibel level of this machine and calculate the new decibel level when a second identical typewriter is added. Now, if I add another one, which means I double the I, which means the decibel level will increase by an additional 3. It should be 73. Now, if you don't see that, you can do the math. With 2 typewriters, okay, 2 typewriters, it's 10 log 2 e to the negative 5, because the intensity now is twice as much, e to the negative 12, and you should get about 73 decibels. Okay. So you're having a conversation at 60 decibel with a friend. At the same time, the intensity level of the street traffic reaching you is 70 decibels. What's the total intensity level in dBs of the combined sounds? Now you can see that 60 decibels is 100 times more intense than 40 decibels. So when you do the combination, your answer is going to be very, very, very close to 60. The 40 is not going to make that much of a difference. So let's try this. So I think what we have to do is we have to find the intensity for I guess the 60. Okay. So if I do the math here, this is going to be 60. If I divide by 10, this is going to be 6. If I get rid of the log, this is going to be 10 to the 6th power. And if I multiply it here, it becomes 10 to the negative 6th power. So I is equal to 10 to the negative 6 watts per square meters. I can do the same thing with the 40 and the I. So instead of 60, you will have 40 here. You'll have 10 log. So this becomes a 4. Get rid of this. This becomes 10 to the 4th power. And if you multiply here, you should get your I. This is I for 60. This is I for 40. 10 to the negative 8. Okay? And that's what I said earlier, that the intensity for 60 is 100 times more than the intensity of 40. So now if you want to find the combined decibel level, you just do 10 log 10 to the negative 6 plus 10 to the negative 8 over 10 to the negative 12. And you should get something that's really, really close to 60. And that something is 60.04 decibels. Okay? Now, if you have something like this as a multiple choice, you know that your answer is going to be just a touch above the 60. All right, 50. Calculate the intensity level generated by a 1 watt point source of sound at a location 3 meters away and 6 meters away. So this is your power. Okay? All right, so we're going to say I is power over surface area, which is 4 pi r squared. That's the surface area of a sphere. Okay, so this is going to be 1 over 4 pi times 3 squared. And you should get I left it as a 1 over as a fraction, 1 over 36 pi. So we're looking for the intensity level, so I'm going to have to find that decibel level. So that's 10 log of the intensity, which is 1 over 36 pi divided by the threshold of hearing. And here we should get 99.47 decibels. Okay? Now, when you are 6 meters away, that's 2 times 3. So your intensity, according to the inverse square law, will be 1/4 of what you have here. Okay, so let's see if we can do this quickly. So the new intensity is 1/4 of 1 over 36 pi. So this is going to be 10 log. I mean, you can do the math and you can just come up with the answer, or you can do it quickly like this. 1/4. Okay, this is the new beta, right? For 6 meters. This is for the 3 meters. Okay, so this is going to be 10 log of 1/4. Okay, plus I separated these two here. Plus 99.47. Now this should be negative. You know that log function is negative between 0 and 1. And that should be 93.44. All right. Let's look at 51. What would be the intensity level of a 23 decibel sound after being amplified 10,000 times? Meaning like the intensity is 10,000 times more. So for each time you multiply by 10, you add a 10 to the decibel level. So this is going to be 23 plus 10, but it's 4 times. So plus 40, and you're pretty much done. For a million, you have to multiply by 10 6 times. So you add, for each 10, you add a 10, so that's 60. So that should be 23 plus 60. Okay. A dog's barking has a sound intensity level of 40 decibels. What would be the intensity level if 2 identical dogs were barking? So now you can do this the long way, where you can find the intensity, double it, and then find the new decibel level, or you can just use your properties of logs to do this the quick way. So beta is going to be 10 log the intensity of 2 dogs divided by threshold of hearing. So if you separate this, it's going to be 10 log 2 plus 10 log I over 10 to the negative 12. Now this is the intensity level for 1 dog. So that's 40, and if you do 10 log 2, you get an additional 3. So that should give you 43. All right, let's look at 53. The intensity of the waves from a point source at a distance d from the source is I. At what distance from the source is the intensity equal to 2I? So let's see. I is equal to power, which doesn't change. That has to do with the source, divided by 4 pi r squared. And r is how far you are from the source that's generating this sound. So if my intensity doubles, right, it means I'm closer. So I have to divide this radius by something so that I end up with a 2 here. But since there is a square there, maybe I should put a radical 2 down there, right? I mean, here they are not using r, they're using d, but I use d. So it should be d over radical 2. Okay. Number 54. Suppose that a sound source is emitting waves uniformly in all directions. So I say 3D. If you move to a point twice as far away from the source, the frequency of the sound waves will, well, the frequency is not going to change because that has to do with the source that's generating this sound. So that's not going to change. Okay. So the sound of a train will be the sound of a train whether you're close to it or you're far away. You will recognize that it's a train or an ambulance or a fire truck. Okay. 55. What is the ratio of the intensity of 2 sound waves with intensity levels of 70 decibels and 40 decibels? So there is a difference of 30 decibels, which is 3 tenths. And for every 10, the intensity increases, or in this case decreases by, for each additional 10 or each drop of 10, the intensity drops by 10. So you're going to reduce by 10 3 times, so intensity is going to drop by 1,000. Okay, so it should be C. 56. If the intensity level by 15 identical engines in a garage is 100 decibels, what's the intensity level generated by each one of these engines? So we're going to do this the quick way. So the decibel level for all 15 is 10 log 15 I. I is the intensity for each over the threshold of hearing. So I'm going to separate this using the rules of logs. So this is going to be 10 log 15 plus 10 log I over I naught, right? Now, this intensity here, that's the decibel level for one machine. So all we have to do now is figure out what this number is, and I know that this is 100, and subtract 10 log 15. And 10 log 15 is 11.76. So we'll say about 12. Okay? That's the beta for 1. So it should be about 88. Okay. Just want to check we're still recording. Right, we're good. All right, let's look at 57. Okay, the sound intensity level 5 meters from a point source is 95 decibels. At what distance will it be 75 decibels? So I think we can find the intensity. So if I go from 95 to 75, it means my intensity dropped by 100. Okay, so the intensity is I over 100. Okay. Okay. So let's do this. 95 equals 10 log I over I naught. Okay, now for 75, this is going to be 10 log. I know the I is I over 100 now for 75 divided by I naught. So I'm going to separate this. So this is going to be 10 log. Okay. Let me see. Trying to find a quick way. All right, maybe we should just find the I. Yeah, I think just find the I. Okay, then we can find the distance. Okay, so this is going to be, the I is going to be, if I divide here, it should be 9.5. This is 10 to the 9.5. And I multiply that by 10 to the negative 12, because this is 10 to the negative 12. So I is going to be 10 to the negative 2.5. Okay. And that's going to be equal to the power divided by 4 pi r squared, which is 5 squared. Okay, so I think we can get the power out of here. And actually, probably we don't need to find the power. Okay, so let's try with 75. So if I do 75 equals 10 log I over 10 to the negative 12. This is a new I for 75. Okay, so this is going to be, I do 7.5 here, get rid of the log, do 10 to the 7.5 power. So the I for 75 should be 10 to the negative 4.5. I think that's what it is. Yeah. And that should be power over 4 pi d squared. So the power is the same. So I think I can say 10 to the negative 2.5 times 4 pi times 5 squared, which is 25, equals 10 to the negative 4.5 times 4 pi, this new distance square. And if we solve for that, we should get a distance of 50 meters. We can probably do this with proportions that I'm thinking about it. Okay. The intensity dropped by 100 times. Right. So if the intensity dropped by 100 times, it means the distance must have increased by 10 times because of the inverse square law. Yeah, I think it's easier this way. So the distance must have increased by 10 times. So 10 times 5 is 50. That's probably quicker. But if you can't do it with proportions, just do it with the way I showed earlier. Okay, 58. You double your distance from a sound source that is radiating equally in all directions. What happens to the intensity level of the sound? Oh, you double the distance. Okay, so if we double the distance, I think we're going to lose 3 decibels. We talked about that many, many times. Okay. Oh, you double the distance, not the intensity. Okay. So if the distance is doubled, the intensity is going to drop by 4. Right? So I can do, the new beta is 10 log I over 4 over 10 to the negative 12. I can separate the 1/4 from this other stuff. So it's going to be 10 log of 1/4 plus 10 log I over 10 to the negative 12. Okay. So this is by how much we're going to change. And if you put that in your calculator, you should get about -6. All right? So it's all proportions. You can do this the long way, but I don't recommend it. I think you just use proportions, use the rules of logs, and you should be all right. 59. By how many decibels does the intensity level of a sound decrease when you triple the distance? So if you triple the distance, I think we're going to do the same thing here. So you're going to change by 10 log 1 over 9, because there is that square for the distance. That's by how much you're going to drop. So, and if you do 10 log of 1/9 or 10 log of 9, and you make that a negative, so 10 log of 9, so that's about 9.54, right? Okay, so it's about 9.5. If the number 60, if the intensity level of one trombone is 70 decibels, calculate a reasonable estimate for the intensity level. Okay. So I think the additional decibel level is just going to be 10 log of 76 plus the old one. Okay? That's by how much you're going to increase your decibel level. And that should be 89 when you do the math. Okay. All right, 61 and 62 don't have anything to do with the intensity, but it has to do with the old stuff. So I just want to make sure you still remember the old stuff. A pipe that is 0.92 meter long is open at both ends. Okay? Vibrates in its second overtone. So the second overtone means that n equals 3. That's the third harmonic. With a frequency of 584. What is the speed of sound in the air in this pipe? So I think we're going to do frequency for the third harmonic is 3 V over 2 times the length of the pipe. And this third harmonic, or the second overtone, is 584. That should give you 358 meters per second. 358.19 to be exact. Okay, 62. An electric guitar is playing a note. An increase in which sound wave characteristic would result in a louder note? Okay. Louder means more energy is in the wave, which means the amplitude. The amplitude tells you how much energy you have in a wave. 2-point sources can generate waves with the same frequency and amplitude. The sources can be turned on and off individually. Rank the intensity of the wave at the labeled point if the left point source is turned on and the right point source is turned off. So this one is off. I'm going to get rid of that. Okay. So let's figure out the intensity. So the intensity has to do just with distance, basically, which follows the inverse square law. So it looks like B is the closest, so it's got to be the loudest. And then A comes next. And it looks like this distance here from this source to D is smaller than the distance to C. So C is the furthest away, so it's going to be, it's going to have the lowest intensity, basically. All right. Rank the intensity of this. All right, now we're going to do the other thing. Now we're going to turn the left one off, okay, and keep this one on, keep the right one on. So the order of the intensity at this point should be B is the closest, okay, still. And then I think D is closer than either C or A. And A and C are equal distance away from the source. So it should be A and C tied for the last place. That should do it. Have a nice day.